this one. Okay, let us start with the lesson 2.6. Do you know there are three equations for motion at a constant acceleration, right? Right. There are three equations of motion that we usually relate. So, first of all, we need to know what are these equations of motion. The first equation is V is equal to V naught plus AT. Okay. And second one is x minus x naught is equal to V naught t plus half AT square. This is for the second one. I will tell you. The third one is 2a x minus x naught p squared minus v naught squared. So these are the three equations of motion. If you look at them carefully, there are 5 variables upon which these three equations are related. What are the variables here? The variables which are included here are, the first one is V. What is V equal to? V is representing final velocity, final speed, because we are talking about straight line path, so speed and velocity are same. The second thing is V naught, which is initial velocity, and initial velocity is the starting one. Whenever something is going to start the motion, so if you start from rest, it is from rest. So if it is written that it is to start from rest, then V naught will be 0 meter per second. Similarly, if something is moving and stops after motion, so then V will be 0. If something is moving and suddenly you apply the brake and it stops, so V will be 0, and the unit is meter per second. Okay, these are the first two things. Third thing is A. A for the acceleration, and acceleration of the object is rate of change in velocity. How the velocity is changing, and its unit that we use is meter per square second. Fourth thing is time, t, the time, and the unit of the time that we need here is seconds. We don't need hours, we don't need minutes, we need seconds. So whenever we will solve any problem, first we will check our units, that velocity is meter per second, acceleration is meter per square second, and time is in second. And last, fifth variable is x. So x is actually your final displacement and x naught is initial. But usually x naught is considered as 0. It is actually your position. So I should write here x is here, x naught is initial position or the beginning position, initial position, and x is the final position. So now we have initial position x naught, final position x, but in general we would prefer x minus x naught as a whole as distance or displacement, and we will use a unit for it as meter. Now keep it in your mind, these three equations you have seen x minus x naught in the parentheses I wrote here. Why I wrote in parentheses? Because this is one component. X naught will always be 0. In these problems we will start from the beginning, from initial position, so x naught will be 0. That's why x minus x naught as a whole is a displacement from initial to final position. You know, the displacement is the movement from initial to final. So x naught is initial, x is final. So final minus initial is your displacement. So now we have these 5 variables. If I write them, this is first, V naught is second, A is third, T is fourth, and x minus x naught is fifth. I will not treat as x minus x naught as 1. Now, if you look at these equations of motion, these equations of motions are related to 4 out of these 5 things. You can see first one. Which one is missing? Which one is missing in first one? There are 4 variables out of 5. Totally there are 5 variables, but each equation contains 4 of them. Like in the first one, x minus x naught is not there. In second one, v is missing. In third one, t is missing. So any question when we will start solving, we need to check what is missing and what is given, and we will solve it. And it's very easy. So here we just found that we have 5 variable. Out of those 5 variable, each equation is having 4 of them. So we will write the data and then we'll say how to write the data, how to solve the question. This is very important thing before we start any problem. So how to use? For that purpose, I'll just give you one way how to use equations of motion to solve a problem. To solve a problem. So what you will do here? First of all, the first step is read the problem carefully and make he said that I told Mr. Sari. Who comes to get you? Does he know that you are going to have problem? Yes. He knows what time it's coming, right? Yeah. You should know. We're trying to avoid the problem that just happened earlier. Okay. His father came and he was looking for his son and. So Mr. Sari also know what we're doing. Yes. He told me because Mr. Sari knows. Yes. Since yep. Sorry to interrupt. No problem. No problem. How to use equation of motion to solve the problem? What we will do? We will make a box. Let me draw it here. Motion will mean velocity. No, motion. These are all related to the motion. So first step is you will make this box. Okay. And how many box these will have? This structure will have 5 boxes. And what you will write here? V naught, A, T, x minus x naught. You will write any given value in it, and the one that is missing you will cross it. For example, let me look at the book. Just give me a second. If I open the book, in the book there are many problems related to this. Where is the book? Yeah, I will open it here. Okay, this is the book and we have, let's say, problem here. I will just go to the problem because examples are already solved. So I would like to solve the problem by the end of the book. And by the way, you have the worksheet. You can also solve. Okay. This is your book. Oh my God. For example, I have question number 22. This is the easiest of all the questions we have. This is question number 22 and I will just rearrange it. Look here, this is the question number 22 and according to the question, a car slows down. A car slows down. So first of all, whenever something slows down, your acceleration is negative. When velocity increases, acceleration positive, velocity decreases, acceleration negative. So it means a car slows down from 28 meter per second. So 28 meter per second is V naught. So I will write here 28 meter per second. To rest. Rest means it will stop. So velocity will be 0 meter per second. Now in 88 meters, 88 meter is the distance. 88 meter displacement. I just write it here. And then they ask us for finding the acceleration. Actually, this acceleration will be deceleration and your answer will be negative because it's slowing down. So what is not mentioned in this one? Time is not mentioned. So I will cross this time. Okay. Now I will choose the equation out of these three which don't have time. First has time, second has time, but third don't have. So I will write this equation and simplify the question. It will give me the answer. For example, third equation of motion is 2a x minus x naught is equal to v squared minus v naught squared. 2 into a is unknown. That's why I keep it as it is. 88 is x minus x naught is equal to v squared is 0 squared minus v naught square is 28 square. So yes.
We wrote 88 because the x naught is 0.
So yeah, I told you all the time x minus x naught is the distance or displacement right away. No need to worry about x and x naught separately. It's one thing. Okay, now you will multiply 2 with 88. So what's the answer? Do you have calculator?
Yes, sir.
Okay, try it. Multiply 2 with 88.
2 with 88?
Yeah, first multiply 88 times 2.
It's 176.
Okay.
88 times 2 is 176. Yes.
Okay. 176 times a is equal to 0 square is 0 minus what is square of 28?
Negative 784.
784. Now both sides you will divide by 176 and 176. So a, as I told you, is negative because it's deceleration. So how much is it?
Sorry. Why didn't you minus it?
I didn't minus it.
Yeah, you divided, but I said, why did we not minus?
Because 176 is multiplied to a. So when something is multiplied, we divide it on the other side. So
the answer is negative 4.45.
Negative 4.45. And usually we write answer in two significant figures. So I can rearrange it. A vector is negative 4.5 and the unit is meter per second squared. So this is your final answer. Okay, let us try one more. Let us try one more for complete understanding. But I will try to choose one that will give some other equation. Okay, question 23. I think it will be using another equation, and it will be enough for us to understand this lesson. This is the last thing, just to practice it. Okay, now let me go to the example 23. Can you read it, please? Yes. Just give me 1 second. I will make it a little bit older. Okay, this is 23. First, what is the first step?
We take that in the notes.
First, we will make a table of variables. Okay. So I am going to make a table of 5 variables: v naught, v, then time a x minus x naught. No, I will make it closed. Can you give me the values, please? If you have. The first thing is accelerated from 14 to 21. So what is 14 meter per second?
It's V naught.
And what is 21?
Initial, sorry, the end. So,
21 meter per second. Okay.
the time is 6 seconds.
Time is 6 seconds. And
you have to know the
acceleration is to find.
So it has a displacement.
Okay, so we don't need this displacement thing. So which equation you remember will be having these four variables and not having the x minus x naught? If we, yes, first one. In second and third, you know there is x minus x naught here and here. In first one, there is no x minus x naught. So what I will do, I will just substitute the values in first equation of motion. That is v is equal to v naught plus at. V is here 21, v naught is 14. Okay, sorry. So 14 plus a is to find and time is 6. Now first step is I will subtract both sides by 14. So 21 minus 14, 7 is equal to 6a. So I got 7 over 6 is equal to a. So finally my answer is 7 over 6, which will be 1.16 1.16 meter per square second. So this is the final answer for that one. So this is how we can continue with this one. Okay. This one is the first thing that we can do it.
Question, please.
Yes, please.
What's the difference between the second and the third